Hello and welcome. Today, we're diving into one of nature's most incredible and, let's face it, beautiful sights. We are talking about rainbows, that amazing arc of color that literally makes you stop and stare. But behind all that beauty, there's some seriously cool physics going on. I mean, it really does feel like magic, right? How you can get this perfect, ordered spectrum of color from just light and water. But it's not magic at all. It's actually a fascinating and very precise dance of physics. So how does it really happen? Let's get into it. All right, first things first, you can't just get a rainbow whenever you want one. The conditions have to be just right. Think of it like a recipe with some very specific ingredients and instructions. Yeah, it's all about your position, a kind of cosmic alignment, if you will. You have to be standing right between the sun and the rain. So the sun needs to be at your back, and it has to be pretty low in the sky. If the sun gets higher than about 42 degrees, the rainbow actually forms below your horizon, so you can't see it. The lower the sun, the higher the rainbow's arc will be. Okay, so we've set the stage. Now, the real star of the show is the light itself. To really get what a rainbow is, we have to understand two key things light does when it hits a raindrop. It bends and it splits. The first critical piece of the puzzle is called refraction. You see, when a ray of sunlight travels out of the air and into a water droplet, it actually slows down, and this change in speed makes the light's path bend. A great way to picture it is like a lawnmower going from the sidewalk onto some thick grass at an angle. One wheel slows down first, and that causes the whole mower to turn. That's pretty much refraction. Now, here's where the color comes from. That white sunlight you see, it isn't really white. It's actually a mix of all of the colors of the spectrum. And because each of those colors has a slightly different wavelength, each one bends at a slightly different angle when it enters the water. This whole process is called dispersion, and it's how a single beam of white light gets fanned out into that beautiful spectrum of colors. The easiest way to wrap your head around this is with a classic glass prism, right? Well, you can think of every single little raindrop in the sky as a tiny spherical version of that prism, taking in sunlight and splitting it into all of its component colors: red, orange, yellow, green, blue, indigo, and violet. So let's zoom in and actually follow a single ray of sunlight on its wild journey through one of these tiny little prisms floating in the sky. It's really like a three-step dance. First, as the sunlight hits the front of the raindrop, it bends and splits into colors. That's a refraction and dispersion. Second, those separated colored rays travel to the back of the droplet, and they literally reflect off the inner surface, like a mirror, bouncing back toward the front. And third, as the light leaves the droplet, it refracts again, bending and spreading those colors out even more on its way to your eye. Now, I want to clear up a common misconception here. A lot of explanations you might hear talk about something called total internal reflection happening inside the drop. Well, for a normal primary rainbow, that's not quite right. It's just a regular, partial reflection off the back of the droplet. This is actually a really important detail, because it means not all the light gets reflected. Some of it escapes out the back. And that helps explain why rainbows can sometimes look a little faint. Okay, so that's what happens in one tiny drop. But a rainbow is made of millions upon millions of them. So how do they all work together to create that huge, perfect arc we see stretched across the sky? Well, the secret is all in the angles. After that whole three-step journey inside the raindrop, the light that comes out is most concentrated at a very specific angle. For red light, that magic angle is about 42 degrees. For violet light, it's a little less, around 40 degrees. This specific angle is the absolute key to a rainbow's shape and color. And here's the really mind-blowing part. Rainbows are actually full circles. The only reason we see an arc is because the ground gets in the way. If you were up in an airplane and the conditions were right, you could actually see the entire 360-degree circle of light. All the raindrops positioned at that perfect 42-degree angle from your eye form a giant circle, and that's what you're seeing. So why are the colors in those nice, neat bands? Well, imagine you're looking up into the rain. The raindrops that are higher in the sky are at just the right angle to send their red light down to your eyes. But to see the violet light, which exits at that slightly lower 40-degree angle, you have to look at raindrops that are a bit lower in the sky. And that's exactly why red is always on the top, on the outside of the arc, and violet is always on the bottom, on the inside. But wait, there's more. Sometimes nature decides to give us a little bonus feature. Let's take a look at a few other amazing rainbow phenomena you might see. I'm sure you've seen a double rainbow before. Well, that second, fainter arc that appears outside the main one, that's created by light that reflects not once, but twice inside the raindrops. This extra bounce does two things. First, more light escapes, which is why the second bow is always fainter. And second, it flips the light ray around, which completely reverses the order of the colors. So in a secondary rainbow, violet is on top and red is on the bottom. And believe it or not, it can get even weirder. Sometimes you might see these faint pastel-colored bands right inside the main rainbow. Those are called supernumerary bows, and they're caused by light waves actually interfering with each other. And then there are the incredibly rare twinned rainbows, where two arcs split from the same base. That happens when you have rain falling in sheets of different sized droplets. So we've gone through the physics, the geometry, all the cool variations, but I want to leave you with one final thought about what a rainbow really is, and it's actually pretty profound. And this leads to an amazing realization. A rainbow isn't a physical thing that's sitting in a specific spot in the sky. It's an optical phenomenon that is completely unique to your position. The rainbow you see is being created by a specific set of raindrops that are reflecting light at the perfect angle directly to your eyes. The person standing right next to you, they're seeing a completely different rainbow made from a completely different set of raindrops. It is, quite literally, a spectacle created just for you. So the next time you're lucky enough to see a rainbow, you'll know there's more to look for than just that main arc. Are you going to spot the fainter, reversed colors of a secondary bow? Or maybe look real close for those delicate supernumerary bands inside? The sky is just full of wonders. You just have to know what to look for. Thanks so much for joining me for this explainer.